Hi everyone, good afternoon. Okay, so welcome to GVO weekly presentation. So today's topic is about Microsoft Windows Azure Service Bus. Okay, so let's look at the today's agenda. Right, so before we go into Azure Enterprise Service Bus, I think it's better to understand what is an ESP, what is an Enterprise Service Bus. So I'm using this term ESP. Why we need an ESP? What are the characteristics available? And what are the available in the marketplace? What sort of ESPs are available at the moment? And then we'll come to today's topic, which is about Azure. Right. Okay. Very simple problem. Now think that I think every one of us are using electronic banking. Now think that when you are logging to your banking system through the browser. Okay. Now what would you see first? You will go to a dashboard, right? Now in the dashboard, things like your name will be displayed, right? And in one section, so that's one section, your personal details, and another section maybe like your account balance, transactions like that, and another section credit card and debit card details, and what sort of transaction that you did, and other things like mutual funds that can be there, and also about attractive loan packages, and maybe if you have already applied for a loan, if you are paying for a loan, what your amounts and what are the balances that you available. Right, likewise. Now these are the these are the dashboard components available in your banking system, right? Okay. Now let's see how this banking system or the browser, the client, how does that show this information, right? Now assume that these components getting data from different services. Okay. Now it can be from different type of services. One maybe those services expose JSON, maybe just a SOAP interface. Maybe it might return CSV, XML. We don't know. Kind of a heterogeneous system. Now, let's talk one by one. Your name and your personal details. Maybe the bank is running with a CRM system. Let's see that they are running dynamic CRM. And I'm sorry, I couldn't change that to Linux, I think. It's running on a Windows application, right? And the account balance, normally banking system, they use COBOL system. That's runs on the mainframe, right? And the credit card, debit card details also coming from another different system, different service that runs on a mainframe, okay? And mutual funds that may be coming from a Ruby or a PHP running on a Windows environment. Your bank loan section get data from a different service. Maybe it might be running on Python. The database might be on PostgreSQL. Nothing. See, different data services in different platforms. It provides different data formats, right? Okay. So how would it work in this environment? Okay, this is kind of a hypothetical scenario. Assume that the app one is your the browser thing. Okay. Now, in order to display these different dashboard components, the app in the sense the service, so it talks to this service, 2, 3, 4 like this. Now assume there are another service, there's another application that it also needs to communicate with these different services. This is how it looks like. Right, maybe you might be satisfied with this environment because the number of applications or number of services are limited. You are not worrying about architecture, or you are not worrying about scalability. You are satisfied. Okay. What happens when you come to this kind of scenario? Now you have 30 number of different systems, and each one of them have to communicate with each other. See how it looks like. Okay. So you understand the problem, right? The problem is that you are directly communicating with each other, right? Okay. Now, what we are suggesting from an ESP, the remedy, would be something like this, which is each application never talks to each other. Instead, it just put whatever the communication content messages to the bus, and from the bus, other application grab the data. Just think this architecture. Okay, right. With this, go forward. What is an ESP? So I hope that you got an understanding what is an ESP. So basically, there are no defined definition for a ESP, but I just took them from the internet. But it basically nothing but an architectural pattern of integrating heterogeneous systems. So that's the simplest definition that we can give for an ESP. Okay, now, right. So now I hope that you get an understanding what normally an ESP does. Okay, now let's, with that understanding, we'll look another step ahead. Right. There is a mobile client. This is kind of a practical scenario. Now, the mobile client, a smartphone, it needs to locate its nearest healthcare center, things like that. So, what it needs to know the current coordinations, longitude and latitudes, right? From there, once it passes that information to whatever the server, whatever the end, it should return the nearest healthcare center. This is the scenario that we are discussing. Okay, how it works is like this. Now the phone, from the phone it has the physical device capable of detecting the GPS location, longitude and latitude. From there it passes it to a. Okay, now before that, assume that your enterprise has these three services. Okay, one service is capable of getting your postal code based on the let's say longitude and latitude, right? So it simply returns a source. So all are exposing source, right? Now once you provide this, it provides an output. That's a definition of service, right? So once you get the postal code, you get the healthcare center codes. There can be many number of healthcare centers available in one location. And finally, once you pass the healthcare center code, you are getting the nearest healthcare center details. Simply as that, maybe like contact details, likewise, right? Okay, now so it's understood, right? So you pass it from this, return it the let's say the location zip code. From there, health codes from here, likewise. So now you see the communication goes here and there. Okay, now how can we address this kind of a scenario with an ESP? Something similar to that what I already mentioned. As the client, you don't need to worry, you don't need to know anything about these services. What you should know about one interface, what you are interested in getting the nearest healthcare center details. For that, it communicate with this enterprise bus, ESP. From the ESP, it will decide whom to talk, how to talk. You don't need to worry about that. Okay? And it will return whatever the information to the service bus. From the service bus again, it talks to the next required service, and it gets the details. Likewise, it ultimately returns the required healthcare center details to the client. So that's the simplest communication happen after you are implementing the ESP. Right. Now, this is actually WSO2 Enterprise Service Bus. I just went through. It's a nice article that they have mentioned. This very simple way. Okay, let's see how this kind of a thing work. We don't need to go very technical. But we'll just understand how things work. Okay, this is it. There are nothing complicated here. It has a thing called mediator. There are important concepts that you have to understand here. In the ESP, you have the mediator, you have the sequence, you have the endpoints, and you have the proxy service, right? So just keep this in mind. I'll discuss this in the next slide. Okay, mediator. So mediator is the component here, you see. So once you get a message, always the message get transferred to the mediator. Mediator knows what to do. It might order the message, it might add quality, it might add security. Everything is being done by the mediator. So what to do is configurable. It's an XML file, right? From there, it passes. So mediator's job is get an input, pass an output. That's it. Simple as that. So it gets the whatever the information, pass it to the next mediator. Then the mediator goes to the endpoint. Okay. Now, since we talk about endpoint, what is an endpoint? Here, endpoint is kind of a logical representation of your real service. Here, if we take the previous example, it might be your actual service. Simple as that. Okay, what is a sequence? Sequence define which mediates the pattern or the pipeline of the mediators. It says, okay, the mediator 1 should execute first. The second mediator should be like this. Likewise, you can configure the order of the mediators to be executed in a sequence. Right. The other important thing, the other attribute is called the proxy service here. Oops. The proxy service. The proxy service here. The proxy service is the virtual service that represent to the outside world. For example, earlier you had 3 services, getting the locations, getting the healthcare center details like that. But instead of those 3 service endpoints, you have only one interface. That is called the proxy endpoint, right? So this is the architecture. How basically this is specific to WSO to ESP. How an ESP works. So we don't need to understand this because this is not our topic, but it's good to know how the architecture of a real world ESP. Right. Now we talk about ESPs. I hope you have an understanding, at least a basic understanding of an ESP. Right. Now let's see the characteristics of an ESP. First thing is called orchestration, service orchestration. Service orchestration is that you are composing different services into one virtual service. So earlier in that SO2 service bus, that instead of 3 services, we had only 1. So the one service knows which service to communicate. The client doesn't know. The client doesn't need to even know about any internal services, just need to worry about the front-end proxy service. Right? So that's what we call as orchestration. Okay. Other thing is about message-oriented middleware. This is the most important topic to our session today. Azure Service Bus. Azure addresses this characteristic. It doesn't address any other things. It's an MOM, which is the communication happens always through an ESP. The sender passes the message to the bus, and the receiver takes the message from the bus. The participants never interact with each other. They just interact with the bus. That's it. So because of this kind of an architecture, the advantages are like sender and the receiver here. The sender and the receiver are never aware of each other. They don't even need to know about that. And other thing is that the sender and the receiver doesn't need to be online at the same time. And they send and receive messages to and from the messaging system. Just assume that you just pass the message to the bus and the other end gets the message from the bus. That's it. Simple as that. Okay, so the responsibility of the MOM system or the ESP, it will decide the destination. It will decide, okay, this message should go to this endpoint, likewise. So you don't need to worry about anything. That much simple. Transformation. Now now here you have to understand about this terminology, cannot share data formats and legacy systems. Now legacy systems are like old days systems, right? They might return the service to the old services might return different data specific to their own customization. Cannot share data formats are the standardized data format. For example, SOAP, XML, JSON, right? So when you are talking to a legacy system, if your system needs to know the format of the message that the legacy system returns to you, it's going to be an overhead. The maintainability is very high, costly. So you don't need to worry about that. Just let the ESB to handle it. It will talk to this particular and the legacy system or whatever the different format system, and it will transfer that data, whatever the legacy system format. The legacy system format, as I said earlier, can be SOAP, JSON, likewise. Message routing. This is part of the MOM model. The application sent to the enterprise service bus, and it is going to the ESB will deliver the message to the relevant queue or whatever the destination, right? So this is what is meant by message routing. It knows the destination. Okay. I think I haven't entered this twice. Sorry about that. Okay. Monitoring and management. This is one of great characteristics provided by Azure. Especially, I will show you Azure how the portal and how you can see the things, what sort of history, what sort of transaction that taken place. Everything can be seen in a dashboard environment. So you can see the monitoring and management can be done through a very easy management model. Okay, now that's about the characteristics of ESBs. Hope you guys understand up to now. Any questions, please feel free to ask. Okay. Now, what are the available ESBs? Among these, these are the most. There are a lot of enterprise service bus available in the market, but among them, there are very famous ESBs. Especially, WSO2 ESB is the most highly used lightweight ESB. Actually, it is being used by very famous clients like big clients like Boeing Airlines, eBay. So that's the most highly used ESB. They actually use open source ESB called Apache Synapse. So they built on top of that Apache Synapse ESB. But I recently hear that they are removing that and they are totally building up from scratch, not relying on Apache Synapse because Apache Synapse is going to be a dead project. Again, Apache Synapse is a ESB available. It's an open source. Mulu ESB. It's an old age ESB. Then you can see IBM WebSphere. It's very famous but very costly. BizTalk Server, Azure Services, Oracle Enterprise Services. There are a lot of ESBs available, but we don't need to understand everything. Okay, now I think it's time to move into our topic. Azure Service Bus. What is an Azure Service Bus? It's simply a message-oriented middleware where you can communicate with the participants, can do communication in a decoupled mode. Right? So under that, there are two main communication or message exchange models happens. One is called broken messaging pattern. Broken messaging pattern, and another thing called relay messaging pattern. So during the presentation, I'm going to address those two areas. So this is just the high-level overview of the service bus. So it has three main entities: queues, relays, and topics. So we are going to discuss these entities. Okay. Right. First topic, service bus queue. It's the normal queue that we know, nothing complicated, very simple. So you have a message center, so you have the ESP, so you have a queue. You can have one queue or you can have a number of queues, and the receiver gets the message from the queue. Simple as that, as I told you earlier. So according to this, so the message producer hands off the message to the queue, and then it continues. It doesn't matter. It doesn't worry about whether my message is being consumed by the other party. No, it doesn't need to know anything about that. Okay. Right now. Yeah. Before that, we need to understand what is meant by the message. Here, the message is something like this. So it has a body area and it has properties. Properties are usually go as key value pairs. For example, I will tell you assume that there is a message that about sales information, right? The seller equals this one, and amount equals this amount, right? So key value goes like that. And the message body, maybe you can store a scanned image of an invoice, likewise. So here it fills the message and put it in the queue. That's it. Simple as that. Okay. Right. Now let's. I will show you how to. Let's first go to the management portal. By the way, GVO, we also have a Azure Service Bus account. But the thing is that you guys can use it, but only we can use queues because of the subscription that we are having. Because of that, I created thanks. Now this is how it. I actually created a test account. Anyone can create. It's valid until for 30 days free trial, but it charged $1. I think just verification process of the banking credit card details. So here you can get all the features available. I mean, I encourage anyone, if someone interested in this Azure portal, there are plenty of things to be done as a presentation. So we took the service bus. So how can you access service bus? Simply just click on this, and you will be able to see this is your dashboard. Now I have created two instances of service buses, not the service bus, actually these are called namespaces. What is a namespace? Namespace is a globally unique container to put all your entities, maybe queues, topics, whatever the entity, to this particular container. This is a unique container. It has to be unique. Right. Now, for that, we'll go from scratch. So I'm going to create a namespace. Okay. So once you click on this, you will get this UI. Namespace name. It has to be unique, and the region, which is about it's better. It's for performance-wise. It's always better to keep closer to your application, where you are going to deploy your application. Okay, I just select East Asia. Let's say my namespace, I'm going to give GVO demo. Let's see if it's available. Yes, it's available. Okay. And the other thing about type, whether you are talking about a messaging MOM pattern or you are going to focus on notification hub. Today's presentation, we are not talking about notification hub. It's a different area. It's about how to send notification to your mobile devices. So don't worry about that. Let's focus on the messaging type. And messaging tier, here you can see, this is about your basic or standard. This is about pricing. Now, if you go with basic, there are cut down features topics. This is what we have at the moment. I use standard because I need to show you during the demonstration certain features. Okay, let's go with this configuration. So now I'm going to create the namespace. It's just a container to put everything inside that. So it takes some time to create. Okay, it got created. I'll give you a demo. It's my namespace. Okay, now let's go inside that and see what in there. All right, now you can see there are, what are the entities? Entities are, again, just to remind, just to refresh, it can be a queue, it can be a topic, it can be a relay, likewise. Right? Now, so first we are going to go with the queue. Now, there are certain ways to create queues. One way is to use the dashboard. From the dashboard, you can manually create a queue. That's one way. Another way is to use the SDK. Now, Azure SDK is capable of accessing the namespace and creating a queue from the program. So you can do that. So I'm going to demo both options. But for the first time, I'm going with the dashboard option. And during the topics, I will show you how to create it from the program. Right, now I'm going to create a queue. Okay, let's see. Create and the name. Geo demo queue. This is my queue name, and the namespace. Took the namespace. Create it. Okay, it got created. Simply as that. Now what can you do with the queue? Queue is there. The containers are there. Now it's just a matter of communicating with your participants. Now this is inside the queue dashboard. Now see what are the available things. The most important thing that I want to know, how to communicate with this queue from my application. That's the most important thing as a programmer. For that I need to know its endpoint. Where is this service at? So how are we going to locate a service, basically, database or whatever? So we need to have a connection string kind of thing. Now, as you can see, when I try to get a connection string, it says that I don't have any SAS policies. This is called shared access service policy, which is when you want to access a queue, you need to define what are the authorizations, what are the capabilities that you can do. Maybe you can create items in the queue. Maybe you can just read items. Maybe you can manage. Those are the rights that a queue provides. Okay, so let's see how you are going to configure that. Here, shared access policies. Now, it's not a complicated thing. Again, if I make you confused, just reminding that this is about you are providing access right. Simple as that, right? The person who is going to write to the queue needs to have write permission. The person who reads from the queue needs to have the read permission. Simple as that. Okay, let's say I'm going to define the permissions. Write permission. What are the permissions available? If you click on this drop down, you will be able to see these things. Manage, send and listen. Manage is like once you click on that, you can do anything. Since I'm only interested in sending, I can select send. Simple as that. Right, read permission. So I can select listen. You have to save it. Right, got created. Now I have two policies. Okay. Now let's go and see the connection strings. Here you can see the endpoints. Now it creates me two endpoints. Now if I want someone to write things to my queue, I can give this connection string to that person. If I want just read permission, something like this. Okay, there is another important thing other than this connection string. Like as I told you earlier, that what if you want someone to create a queue? In that case, the best thing would be to give the connection string for the namespace. SAS key for the namespace. Don't go, because you are letting someone to create a queue. So in that case, the queue is not exist. So what you have to do is you need to give the permission to the container. Okay. For that, you will be able to see. Go back, and you can see the namespace. From the namespace, I can get the connection string information. Sorry. the primary keys and secondary keys. Okay, now let's try to communicate the queue to our application. So before that, we need to have some DLLs. Now this DLL can be downloaded from NuGet package. It's really easy, nothing complicated here. Okay, I'm going to open the Visual Studio first. I'm going to create a new project. Okay, this is going to be a simple console application. So what it does is it's going to send a message to the queue, and it is going to consume from the queue. Simple as that. Okay, let's say my top project name. P2. Okay. Right. For now, I will just try to explain each line by line, but in other example onwards, I just use the existing code and show. But if the time, based on the time, I'll see what we can do. Right. First of all, what you have to do is you need to add the DLLs or the SDK from the NuGet package. So as we all aware, you can just go to NuGet and you can download that. Just type service. By the way, like it is not limited to .NET. If you have a client in Java, if you have if your development in a Node.js, SDKs are available for Java as well as Node.js. So this is about for the .NET. So I'm just installing this. Okay, it added DLLs. So what we are interested in here is the namespace Microsoft Service Bus. Okay, let me quickly add a new class which is going to define how we are going to communicate with the USB. I'm defining as queue manager. Okay, this is a static class. Okay, now what we are going to do is this class has two methods, one to send messages, one to receive messages. Okay, let me first add the method to send messages. Public static, right. Send messages. Okay. Now the first thing that you have to get here is a connection to the queue. Simple as that. So how are we going to get the connection? Connection is defined in the connection string that I showed you in the earlier dashboard. So you have to define where is your endpoint at here. So now endpoint can be obtained from the dashboard. So you can go to the queue and here from the connection string, write permission. Okay. Now I'm going to have two. You can just copy it from here and paste it. Okay. Now I'm going to just modify this as let's say write connection string. I'm going to have two clients, so I'm going to provide two endpoints. The other one is going to be a read connection string, and going to get that as well. Okay, got copied. Endpoint is being added. Okay, so the basic configuration, now the application knows where to communicate. Right, for that we need to have a queue client. Okay, this queue client is smart enough to communicate, open a connection to the endpoint and pass the message to the endpoint. Okay, let's say send client. first you need to know the endpoint. So I'm going to provide the connection string. So how can you get the connection string? Connection string is in here. For that you need to read this value. I think because of the time that it goes, if I type this thing, it's going to take some time. So I will explain. I will just copy paste the codes, but I will explain you what's happened. Otherwise, it's going to take some time. Right. So I have already I have a class which I already wrote that application. Okay, let's get this one. Okay, just pasting here. Right. So you need to have these namespaces in your project. Cloud Configuration Manager. This one is going to read the connection string from your app config. Yeah, so now the connection string I have to now we are going to I'm not going to write anything, I'm not going to create a queue, so I don't need that. What I'm interested in sending something to the queue. So the key is like this. Now it get the connection string and it initiate the queue client object, and I'm not going to add this much of messages. Just one message I'm going to, for simplicity, I'm just adding one message. This is just a list, and this is the most important thing, which is the broker message. Broker message is the one that I already mentioned you, that it has key value properties as well as the body. Now, if you want to pass a message, first create the brokered message instance and add whatever the information that you want and pass it. Simple as that. So here you can see it just loop through the array list, and it sent. That's it. Now this is going to send it to the queue. Right. Let's go to the receiving part. How it works is very obvious, nothing serious. Again, it get the connection string and create the queue client. All you need is a queue client. Here, queue client, and the queue client is going to read. This is called the receive, and this is just timeout. How much you are going to wait till end, and then this is going to the message object. So you got the message and you are just printing the message to the console. That's simple as that. Alright, so here you can see the message body. This part that I already mentioned you earlier. We are not using any key value properties. Just simple message to be sent. Okay, let's see how this goes. Yeah.
Regarding the receiving from the queue, is there a built-in listening mechanism rather than me trying to call receive with the timeout? Is there Azure contacting our server saying, hey, you have a message?
No. Now that's what you are I think expecting from subscriber topic. I also thought like that initially, but it's not the case. What subscription means that it passes the message to the subscriber. It's another queue. That's it. You should be able to create that queue. Your application is not getting that signal that okay, there is a new message being arrived. No such thing.
Yeah, it's like when we read from the queue, the message will be still there in the queue, or
it's get deleted. Yeah. Now there are two ways. You have two ways. Actually, you have to configure two ways. Here you can see this is I wanted to highlight. There are two receive modes. One is called receive and delete, and other one is called peak lock. It's really interesting. Now peak lock it means like it it locks the message until you consume, until you finish processing, it keeps the message. Receive and delete means once the client grabs the message, it deletes it from the queue. Why we are having this kind of scenarios, two lock modes, is that assume that once the client got the message and then the queue directly removes it, what happens if the client crashes before processing it? If your application is that much sensitive, you have to go with peak lock. Peak lock does not delete the message until you specifically send the complete complete command. Right? So here it just deleted. Right, and there are some settings I think which is important to understand in the queue about how long you want to keep the message without consuming. So those things can be configured from the dashboard. Yeah, here. So you can see the default message time to live is 14 days. So you can configure according to your requirement. By default, one queue is capable enough of supporting up to 5 GB of data, storage data. I'm also not that very much familiar with these other some attributes, but lock duration, like you are locking the, if you are using the peak lock, how long you are going to lock the message. Likewise, lock duration. Maximum delivery count. It is something like this. Now, assume that you try to grab the message and still you are not be able to get it due to some reason, you don't know. You try 10 times and still you are not be able to get it. In that case, it is the manager doesn't keep this message in the queue after 10 times of trying. It removes from the queue. So you can configure that as well. Things like that. Okay. Okay. Now the time is the problem. I will quickly configure this thing to work. Right, now let's go and execute this. Sorry, thanks. Spot on, thanks. Yes. Not only that, I missed the queue part as well. Queue name. So this is the queue name. So what is our queue name? Queue name is GVO demo queue. So we have to change that as well. And the connection string. Yes. We need to have the right connection string. Yeah, right connection string is there. Read connection string I had to update. Thanks. Okay. Okay, now let's go and execute our program. Queue manager.execute. So that's all I execute. Queue manager.execute here. Okay, so what it should do, it should send the message and it should retrieve the message. Let's see. Okay. So it said that it sent the message. Okay, it received the message. So you can see it's a very simple thing, not very much complicated. So I'm quickly moving to the
yeah. Show the structure of the message.
Yeah. Yeah.
Programs.
Sorry. Let me show you that. This message ID is one that we entered manually, and there are properties that you can add, key value pairs. So you can add any number of key value pairs.
Is it object? Key value pair, the value is object or strings?
It's a string.
Value is also
Yes,
strings.
yes,
In the property.
yes. But what you can do is, if you want to store an object, serializable object can be stored in the body. The body.
They are separate the body.
Yeah, I showed you earlier.
Properties is like metadata of the message.
Not metadata, not metadata. It's about, like, you don't know what sort of things that you are going to enter the message. There's no specific schema. So you just add things, key and a value. Simple as that. I just took a very simple example. If you want, I can just show you that.
That's fine.
Let me see that as well. Now let's see. Message dot properties dot add. Oh, sorry, I think you can add an object. Yes, you can add an object. Yes. Okay, right. Now let's move to the next topic, which is so we discussed up to queues. Now let's go to the last topics and subscription. It is also not a very complicated pattern. Now, instead of one queue, it sends the application send the data to a topic. Right? Topic is like an interested area. Now, the topic, if the topic has subscriptions, what happens when a topic receives a message? It gets a copy of each message, and the number of subscriptions that it has, it passes to the subscriptions. For example, if you receive a message called message A, each of the copies of the message will be going to subscription. But from the message receiver, it needs to get this is again a queue, not a very complicated thing. It reads from the queue, but the subscriber gets the data from the topic. That's what it is. This is actually topic subscription pattern. Topic subscription pattern. Okay. Now, if I go for the coding, but here another interesting area here is that now what if the subscription also need to filter things? Now let's say a message arrives about some sales information, right? This subscription is about, let's say, by area Colombo area, and this one about Mathura. Now, if you don't need to worry about Colombo, if the Mathura subscription doesn't need to worry about Colombo, so you can filter the messages that the topic puts to the subscription by adding filters. Those filters are called as SQL filters. So for the subscription you can add. So I will show you how to create those filters and how to put messages. Again, you can add a topic from the dashboard. Go to the topic section and you can create a new topic, but this time I'm not going to create topic from here. As I said earlier, I'm going to create from the application. We'll quickly do that. Okay. This one. Right. Now I'm going to add a new class that handles the topics. Topics manager. Okay, this is also again a topics class. Okay. Simplicity, I just add this. Same as earlier connection string, getting the connection strings. But I think you need to have the connection of the SAS key, as I said earlier, for the topic. Now here, this is the important thing, because it is very much similar to queue. What differs from the earlier is this: you add a new filter called SQL filter to this particular subscription. Here you have a subscription. You are saying, okay, give me only Colombo subscriptions. Then the topic, when it gets distribute copies, it only put the relevant message to the relevant subscription. Okay, I think it's so here you can create a topic in the namespace manager. Now for this, you need to have the namespace manager, the managing rights to create something on the your namespace. So you are going to create it from here, topic, and then after you create the topic, you have to create the subscription as well. So this is how we are going to create a subscription from the namespace manager. Again, create a subscription. The path is the name of the path, topic path, topic name, and the subscription name, whatever the filters that you add. Simple as that, and that's it. After that, you are going to send the messages. So you are just here. You just add here again a brokered message, nothing different from the queues, and you have now instead of a queue client, now you have a topic client. The topic client class is going to create a topic from the topic name. Likewise, you will be able to create topics, and then when you are receiving, now for each subscription you have to listen, right? Now this the Colombo subscription, this one is listening, receiving from that subscription, and here you can see the other subscription, All Island subscription. So this is from here. Likewise. Okay, I'm not going to run this application. It's going to take some time. Okay, let's go into the final end of the presentation. Okay, so we discussed queues. Now we discussed topics and subscription, and final thing is all service bus relay. I told you earlier that there are two messaging patterns. One is called brokered messaging, and another one is relay packet. Brokered one is, you know, the broker. What is a broker do? It just is an intermediate person. It sits between two people and gets something and passes. Something like that. Now, in the previous section, you saw the queue and the topics are the brokers. Here, relay, it's like, you know, sports that you can see the relay thing. You just pass it. That's all. You don't keep it. Now, this kind of a pattern is matching if both ends has to be online at the same time, and the one party doesn't need to know about the location or anything about the other party. There's no direct communication. Always point-to-point communication might give bad design. So instead of directly relying on each other, it rely on the relay, service bus relay. So whatever the things it pass to the relay get the message and pass it to the relevant application. Simple as that. Why we are another reason might be that I think that the service that you are hosting inside. Now, other thing that I need to highlight, these two applications, one might reside in on-premises, right? And other might, see the dynamic CRM, it resides on the cloud. Now, now we also having this kind of a similar project we are doing. There's a Sage application, so it's inside the premises, and Dynamics is another cloud. So without directly these two communicating with each other, it goes through this. Now assume that this is kind of web service thing, and it does not adhere to the latest keywords, quality of service, quality of service like WS standards. And if that service doesn't have this, this can add those keywords, quality of services, to this service. It's kind of wrapping your existing service like that. Yeah. So this is another way, but I'm not using any samples to demo this. Okay. The final slide. When to use ESP. It is not always recommended to. If you do not have a direct requirement, don't just make your things complicated, right? It doesn't say that the point-to-point communication is always bad, nothing such. But it is always recommended, like if you're integrating 3 or more applications, it's better to go with ESP. But also, like I already told you about the rules of ESP, and the CTO of that company, even they are the producers of ESP, they said that he also said that unless you really need a ESP, don't make your architecture complicated. Make things very simple, unless you really need it. And if you are extending more and more applications, if you have plugin things in future, you might need to go with an ESP. And also, like if you need more than one type of communication protocols, like things like this. Yeah, I think so. That's reached the end.